Well, thank you very much. Thanks for taking your precious time to attend. Thank you to Eberhard for inviting me to speak, and the GOTO conference, very first-class conference, so thank you. So what I'm going to talk about today is using DDD in our modern times. So what is contemporary DDD like? Actually, this talk is meant to underwhelm you a bit, because remember, I'm a champion of simplicity, okay? So whatever I'm going to say is going to be the simplest thing that could possibly work, okay? And what I'm going to do is hopefully show you how to cut through a lot of the maybe misunderstandings or complexities, accidental or even purposeful complexities that you may use as you develop. So what is domain-driven design about today? So actually, domain-driven design hasn't really changed since Eric Evans codified the patterns, what is it now, 14 years ago or something like that. The essence of domain-driven design is still modeling a ubiquitous language in a bounded context. What probably has changed is the way that a bounded context is rendered into production these days. If you look carefully at Eric's book and you sort of maybe even a little bit read between the lines, I think you can tell that Eric was not opposed at all to developing a monolith, but a well-structured, a well-modularized, well-designed monolith. And so potentially you could actually have multiple bounded contexts within one single deployable unit. Of course, I'm not trying to read his mind. This is just my interpretation of his expressions back, at or before the year 2003. So, bounded context, ubiquitous language, still the hallmark of domain-driven design, but because we have a bounded context, a boundary where we model a ubiquitous language, we will always have multiple bounded contexts. It's just because the scope of a bounded context should be quite limited. The scope of your bounded context should be limited to just the language that your team speaks and develops and then is reflected in a domain model. So yesterday I was asked the question, where do you keep the model as opposed to the code? And again, a very important design philosophy of domain-driven design is the fact that the model is the code. So you don't draw UML diagrams as a model and then write code afterwards. They are one and the same. And so you'll see this model reflected, as I had here, in a single bounded context, maybe using objects. You don't have to use objects. You could use functional programming. These could be records or structures that are being passed around to functions. But since you have this kind of a boundary around a context where you speak a specific ubiquitous language, you're going to have multiple ubiquitous languages, multiple bounded contexts. And these days you will see the multiple bounded contexts rendered into multiple processes. And if you will, I can't be any different than most of the other speakers here. We have to say something about microservices. So you could think of a bounded context as a microservice. And I think that's a worthy approach, not always, but it can be, especially if your language tends to be small. It's at least a good first approach because you may have reasons to break a specific entity or aggregate out of a single deployment unit for scaling or whatever it may happen to be. Perhaps the rate of change is different than the rest of the bounded context, and so you want the freedom to iterate on this more rapidly than the rest of the bounded context. There may be various reasons to deploy differently, but if you start with the idea that a bounded context is a microservice, it's an excellent place to start. And keep the bounded context small. So when you consider the way that computing is going these days, I'll tell you, I must be next to something that's blocking my signal. There we go. What is this? What is it? Okay. You know, actually it could be interpreted in a lot of different ways. Probably when you first look at it, you say, I'm looking at some sort of a galaxy, you know, the stars in a galaxy. But actually, could this possibly be the atoms in a human cell? So when we zoom at powers of 10, things tend to look like things at other levels. And this can be true of, you know, is this all the systems, light points that are representing all the systems on the internet? Or is it a light point of all the actors running in a single system? It could have several interpretations, but what this illustrates is that when we have so many things happening in our computing systems, regardless of whether we're using monolith, integrating with many bounded contexts or unbounded legacy systems, whatever it happens to be, we are dealing with uncertainty everywhere. Non-determinism, because we don't know when a ray of light will reach one place or the other. And we don't know what order the ray of light will appear in one place or another. There may be factors that we aren't anticipating. So I wanted to clear something up about what Donald Knuth said. I've never met Donald Knuth, so I'm not you know, like the Donald Knuth expert here or trying to speak for him. But most people remember this statement by Donald Knuth, right? It says, premature optimization is the root of all evil. Okay, this is true, but sometimes this is used against optimization. Do you know what Donald Knuth actually said? If you look up the full quote, this is what he said. We should forget about small inefficiencies. Premature optimization is the root of all evil. So there are some obvious optimizations that we should use and should take advantage of in our computing. Otherwise, something else that Donald Knuth said will be true of us. So for people who are more than casually interested in computers and writing software, we must have some idea of the underlying hardware, what we are developing for, and the environment that we're developing in. Otherwise, the programs we write will be pretty weird. I love that statement. You know, it just says it all, that we've tended, you know, over the years to move further and further away from a knowledge of the hardware. I used to have to know a lot about microprocessors, a lot about the memory available in a small PC. I started developing software when the IBM PC was brand new, dual floppies, and the best we could do in those days was about 256K of RAM. Okay. Since then, we've tended to just, you know, put layer upon layer upon layer, and we don't know how things really work inside. But I think that it's going to be necessary for developers to start really taking this seriously in the next few years. And here's a good reason why. So if you go all the way back to the year 1973, and I'll mention in a moment why I'm using the year 1973. You can see that the prediction was made even earlier by Moore's law, or Moore's prediction, if you will, that microprocessors would continue to just about, double in speed every few years. And that trend continued to happen, and also that the transistors in microprocessors would continue to grow year over year. That second trend has continued. But in about the year 2003, we reached a level where, for various reasons, microprocessors could not perform in the same sort of doubling in speed growth or speed that they had in past years. So what did change is the fact that cores and hyperthreading started to be evident in processors. Now, I know this isn't new news to you, but how many software projects are really not using the cores in a microprocessor to their best advantage? If you are, however, welcome to uncertainty. The reason that I mentioned the year 2003, it's when Carl Hewitt and some colleagues came up with the idea of actors, as in actors as the primitive objects in computing, the primitive elements or concepts within computing. And actors and the actor model and actor systems became very, way ahead of their time. Okay, Carl Hewitt was at least 10 years or 12 years ahead of his time, because Joe Armstrong didn't sort of reinvent actors in industry without even knowing of the work of Carl Hewitt, or not much about it anyway, when he and his team started to develop the Erlang language. So when you start using tools like the actor model, concurrency, or at least asynchrony, becomes a real thing. And that is because multiple actors are operating in different time frames than other actors. And they're acting based on the messages that they have in their mailbox, and they're acting based on the slice of the processor or core that they get at any given time, basically a thread. But regardless of how our individual bounded contexts or microservices are implemented internally, we still have asynchrony or concurrency and non-determinism around the entire system, because we are publishing domain events out of a bounded context, most likely, at least if you're using the most robust approach to integration and collaboration within bounded contexts. Then you're using events, and other bounded contexts are reacting to your events, even if internally we still use a blocking metaphor or a blocking paradigm, I should say, for processing the events internally. So when you face this situation, welcome to uncertainty. Right? This is what our brains want. This is what our brains want. We want event 1, 2, and 3 to hit a disk in that order, and we want to read those events out in the same order, and we want to react to them exactly in that order. That's just what we want. Our brains crave it. Now, I think that there are probably some here who have already embraced the ideas of concurrency, parallelism, actor model, and so forth, and they're at least getting used to, if not very experienced in this. But this is not the way things happen. Sometimes it happens that way, but anybody who tries to sell you exactly once delivery and exact ordered delivery is really not being completely forthright, because it's impossible. And if there is even the possibility, a single possibility, for this event or this event to arrive out of order, you have to plan for it to always happen. So you may as well plan in and design into your software that uncertainty in a distributed system is just a fact. It's something that you're going to have to live with. So I found this really great definition for uncertainty. It's the state of being uncertain. And, well, you know what? That's saying, okay, I'm Mr. Obvious, right? Or Webster's dictionary is obvious. But, you know, it does give us a hint about something. Uncertainty is a state. Ah, okay, we're used to dealing with state. If we are in the state of uncertainty, we can reason about that state and design around it. So let's take it from there. Uncertainty has synonyms: unpredictability, unreliability, riskiness, chanciness, precariousness, changeability, variability. You know what all of these really, this one synonym for all of these synonyms? It makes us uncomfortable, right? We're just like, ooh. And, you know, I know what you're thinking right now, especially if you live in Germany. You're saying, I face uncertainty every single morning. I mean, the first thing in the morning. The German bathtub that sort of, kind of acts like a shower, but not entirely. Do you know the difference between the level of the floor and the level of the bottom of the bathtub and the height that you have to lift your leg into a slippery surface? It's just crazy. I don't know. You know, it's like the German bathtub designer said, well, okay, you got to clean yourself, so here you go. You know, but, you know, here's how I look at it. I mean, even this morning, now, don't picture this too carefully. I lift my left leg, and I start to step into this, and I realize, you know what? This isn't like taking a shower at all. This is like going on a hike, you know, in your bare feet, on a slippery surface. Two of those things which I would almost certainly never choose to do on my own, okay? Now you get into the bathtub and it's way too narrow. There are angles on the side. Again, it's slippery. If you don't stay right in the center and kind of shimmy up to the water, it could be complete disaster. But finally, now here's really the thing about the uncertainty of the German bathtub is when you're done, right? Now it's the opposite. Now you have to lift your leg out and step onto a lower surface by propelling yourself forward, which means this foot is going to slip, this foot's going to hit a towel that's on tile, right? And I mean, do I have to explain any further the real reason for Germany not having babies? So, I mean, you got to call it the way it is. So, here's the thing. Americans are addicted to flat showers with a lot of room in them. I have to admit. But does that mean that I won't take a shower in Germany? No. But it's sort of like our addiction. We have an addiction to blocking, right? A client object, not another system. I'm just talking about a Java object or whatever kind of object in some VM making a method invocation on another object. Let's call it a server because it provides some service. And this is a blocking invocation. And you know what? We just feel awesome about that, don't we? We're like, oh, man, I know nothing else in the whole world, my whole universe is just comfortable right now because I know nothing else is going to happen until this server finishes and I have some kind of result and I'll deal with that in some way. Okay? So we're addicted to that kind of thinking. We're also addicted to exactly once delivery and total ordering. That's the way our brain wants to think. We're addicted to storage that is completely transactional, and not just transactional on a single data source, a single schema or table or whatever it happens to be, but we want transactional consistency every place all at once, right? XA, global transaction, two-phase commit, whatever you'd like to call it. Now, what I want to tell you is that being uncomfortable is okay. And just like I have to figure out how to take a shower in Germany without killing myself, we have to figure out how to use distributed systems in a non-destructive way, in a way where even though we can't predict what's going to happen next, we can still deal with it. So don't be afraid of this feeling. Now, here's another way to compare this. Do you know that this is called an autostereogram? Do you know what's in this autostereogram? So you see this sort of graphic that makes almost no sense. There's maybe a little pattern here and there that you can trace. But if you squint your eyes and sort of slightly cross one or both eyes, there's a shark in there. Does anyone here see it? Some people see it like, okay, the few. Some people just see it like, I don't know why. I have to try hard to see it, but I can see it now. I've trained myself to see it. And after you train yourself to see the image that is carefully hidden in the audio stereogram, or auto stereogram, then you can then start to readily see them. And you can just pick them out because you teach yourself, you learn to be comfortable with the carefully concealed object and deal with it. And I think that this sort of describes the situation that we're in with our processors these days. Carefully hidden in this processor is multiple cores. They're available to us. We should be using them, and we should be using them intelligently. To get our jobs done quicker, we need to break up tasks and make them happen concurrently or in parallel. And so what happens to us because we're addicted to certainty, to blocking, to synchronous operations, total ordering, absolute guarantees, right? Then we want to tend to build a fortress around our bounded contexts. And this fortress can be rendered like this. So here we have a domain event wandering in, it's finding its way in to our bounded context. And ultimately, we want to do something in our domain model that reflects or reacts to this fact that we see coming in from the outside. But before we let the domain model have it, what we're going to do is build a fortress at our infrastructure layer. And this fortress is going to guarantee that there are no duplicates of this particular event, and that this event is received and dealt with, well, not received, but dealt with in the exact ordering that it occurred, okay? That's what we want to do. And so we build structures like this. We create a de-duplicator so that if we see event 1 coming in again to our bounded context, we make certain that event 1 is only seen once. And we also resequence so that if event 2 is latent and it's finally received, we're going to we're going to store away all of these events until 2 arrives, and then once the ordered events have been fully seen in a block, we're going to release them to the inside. That's because we're trying to model for certainty. We want to deal with things in that way. Do you know one of the major problems with this? It's hard. It's really hard to get this stuff right. It takes a lot of storage to, persist these things, and when can we delete them? When is it safe to delete the fact that we've finally seen event 2 in order? When is it safe to delete, in this case, delete events 1, 2, and 3 from here because we've already seen them, and we don't have to worry about seeing them ever again, right? Is it after a day? Is it after a few days or a week? I mean, who can tell when this could possibly happen again? And so when you find yourself in either one of these situations, right, it becomes hard. And you know what? We haven't solved any business problems yet, right? And that's really what we should be doing, is solving business problems. So let go of all this, overhead, and learn how to model uncertainty. Otherwise, you're going to be stuck in this situation, right? Where you say, stop everything, right? Stop everything. Okay, go ahead, I'm ready now, right? We can't continue to model software that way because there is no now. There is no now. There's actually an urgent global bug. It's an insidious bug that's universally infecting all systems. This is it, right? So look out for that. Uncertainty then. How do we deal with uncertainty? Distributed systems are here to stay. I said this some months ago. I didn't think it was that funny, but people just laughed like crazy. I said, distributed systems are here to stay. If you don't like it, change careers. Like maybe open a restaurant. If you open a restaurant, you're only going to be using distributed systems. You won't be developing them anymore, okay? So modeling uncertainty matters. It matters because cores matter, the cloud matters. We're deploying in the cloud. Things are coming and going dynamically. Things crash. Things get restored. It's there. It's a real thing. Microservices matter. It matters to be able to change your cadence on any given microservice or the rate of change or the scalability. Latency matters because networks are everywhere. And not only networks, but networks of things, right? Internet of things. And all of these things are cheap. They're all cheap, and therefore, they're happening. They're a fact. If you want to interview for another job, a year or two from now, you're probably going to have to know a lot about this if you don't already, okay? So, what do we do about it? One thing that Alan Kay said, and I got to tell you, I'm a big fan of Alan Kay, being an old small talker. Alan Kay to me just has so many brilliant things to say, except for where we disagree. But one thing that he says that I heartily agree with is that the interesting thing about objects is not the implementation of the internal object. It's the messages between the objects. So the names of the objects, as in the roles that they play, and the messages that are exchanged between them are the interesting things. And Alan Kay refers to this as the ma, okay? The ma. This is a Japanese term that I may not be saying completely correctly, but ma basically means what exists between. And so he says this is what he really felt was the important thing about the object idea. Now, a lot of us have spent a decade or 2 decades or more thinking about the inside of these things primarily, right? Solid. I'm not disrespecting solid. It's a good design principle. But we can take that too far because imagine that this thing is potentially a messy machine internally. It's an actor, right? It receives an asynchronous message. Is it really super important that I am obeying the open-close principle in this very case, right? What really matters is that I have a design that is good enough to handle this incoming message specifically. And what's interesting is the names and the roles of the two objects and the name of the message, the intent that is meant to occur, is our ubiquitous language. That's what DDD emphasizes, is the ubiquitous language. And so here is the real thing about asynchronicity, concurrency, parallelism, along with object design. Think about the messages in between. And we're developing reactive systems, so we have to think about the messages in between other little machines, microservices. So here's the state of being uncertain. Pat Helland, have you read his paper, Life Beyond Distributed Transactions? Who here has read that? Not enough. I'm telling you, you have to go read this paper. It actually agrees with DDD entirely, you know. And I don't know what Pat Helland knows about DDD, but this is what Pat Helland said in this paper, which has even been updated, Life Beyond Distributed Transactions. He says that in a system where you can't count on distributed transactions, the management of uncertainty must be implemented in the business logic, okay? It has to be. And Pat Helland recognizes this. Now, Pat Helland discusses this idea of an activity. It's a partner activity. So two entities, regardless of where they're, you know, which bounded context they're in, one might be in orders, the other one might be in fulfillment, whatever, but they exchange messages. And the receipt of a message is called a partner activity. The sending of a message is called a partner activity. And Pat Helland says that here's an idea that you can use for dealing with the uncertainty or modeling uncertainty. Now, Pat Helland doesn't go deep into how you would actually perform this, but when I read his paper, this is just kind of the idea that I get. I get the idea that, an activity, it can be modeled as partner activities where we're going to record an activity. So we have a partner, which is basically an entity somewhere, right? That's our partner. And the activity that they are telling us to perform, this becomes a pair, and this pair is going to be maintained internally in our entity, in our local entity, because that's our partner, and we have to know if we've seen that before. Now, you could model uncertainty in this way. It can take a lot of extra storage, though. It can take a lot of overhead to reload these over time if partner activities continue on and on over a long period of time. And even Pat Helland says, you got to think about this because there can be an enormous amount of in-memory, RAM used or in-process RAM used, and a lot in persistence and so forth. So I want to take this further. Where should we actually put this? I think it needs to be in the heart of the software, right? Let's model this because we are in the business of using distributed computing. It's a matter of fact. We can't escape the fact that distributed computing is an absolute necessity from now and moving forward. It's just the way it's going to be. And so it's part of our business. It's part of the business model, and we embrace it. And so we accept the fact that we have uncertainty, and it's actually less complex, right? It's less complex, and I'm going to prove that it's less complex to model it this way. So we need an explicit model, right? We have our actors or our aggregates, entities, whatever you want to call them. Events are flowing all around. These are the orange little objects, and the blue objects are commands, and they're going everywhere, and some of them are being filtered into a bounded context and being acted on, and others are being ignored, and events are being emitted, and we just keep doing this. So we have to identify our core domain. And let me just say, if you're working in this environment, which is a P2P, peer-to-peer economy where clients are proposing short jobs that need to be done. It could be anything from I need someone to walk my dog to I have a broken window, please come and fix my window. And then some worker somewhere is going to say, I'll do that job and I agree with your pricing and so forth, right? And you might look at this and say, yeah, the front end. This is so important. We want this to be an engaging user interface for the matching between clients and workers. But where do you think the real core domain is? Where do you really make money in this situation? You know, it's actually probably in pricing. Because we have to make certain that we know the kind of job that's being done in a specific demographic, neighborhood, whatever it happens to be, and we have to know that job is being fairly priced by the client and the worker is accepting a fair price and so forth. And what if it's scheduled on a holiday? We want to make sure that the worker makes more money because it's a holiday. We want to make sure that we make more money because we are managing this on a holiday. You know, we're trying to find out where do we want to put our investment in knowledge. And I'm going to say it's probably not mostly here. It's probably in pricing. So you have to choose your core domain carefully. So from matching, when a client proposes a job, a client job proposal will emit a proposal submitted event. This proposal submitted event will be seen in pricing and it will be seen in scheduling. And then each of these bounded contexts will do some kind of, business logic that will say that the pricing is denied or the pricing is approved, for example, or the scheduling is denied and the scheduling is approved. Okay, a fairly simple use case, but it is a distributed use case. So how do we deal with these kinds of situations when they happen in duplicate, when they happen out of order? So here's a situation where we might receive the same event multiple times, which means we're going to translate that event to the same command multiple times, and it's going to be received by some entity multiple times. Actually, the simple solution to this is keep a simple state that allows you to determine, have I seen this command already? Okay? So what this means is it doesn't matter how many times that you've seen this event and translated the command, the entity is going to only modify its value once, this particular relationship or association, and it's going to emit a single event. That was the commutative one. The non-commutative operation is, you still receive multiple events translated to multiple commands, but we need to have some kind of identity. Again, sort of like that partner activity that allows us to look back and say, have I seen this particular activity from this particular partner, right? And so we not only keep a state, but we keep an ID associated with that state, but still it can become a definite part of our model. We can do similar things with a sequence that's in order. What if we receive event 2 out of order and we process, event 1 and 3 and they become command, corresponding to 1 and 3, and now we have some uncertainty here because step 1 has occurred, step 3 has occurred, but step 2 hasn't occurred yet. What do? You just wait for step 3 to occur, and then you do something about it. You emit an event that says this little mini process has completed, right? And you're using the same kind of look back or state, machine here that says step 1, 2, and 3 has completed. And you know what? You're modeling the business. This is the way the business works now. It's non-deterministic. We can't tell. We don't even know if this will actually eventually happen, but I'll talk about timing in a few minutes. Okay, what if we want to model the closest fulfillment center, right? Okay, we simply look for some kind of indication that a fulfillment center has replied to us through an event, and it's telling us the distance and the time frame, for example, that they can operate in. And so we choose the closest. When we have multiple choice, we might choose the first or the fastest. So in this case, even though 1.3 may not be the closest, it was the fastest responder, and still we're going to choose that responder. And when the others finally arrive, what do? We can note that they arrived, but we aren't going to emit a new event because we've already chosen the first. And sometimes it's necessary to model a process manager. Now, again, don't be afraid of this. It looks kind of like, this crazy spider that has poison and you're afraid of it. But actually, really, it's just some aggregates or entities that are emitting events very similar to what we just walked through, and the process manager is a central location to track that, and then the process manager emits commands to get other work done as it sees this workflow occur. And of course, we have to deal with timing, because timing is, what if we never receive that second or third event or fourth or fifth or whatever it happens to be? Well, we need some way to look back and find out where this event could be, but it's also good to know what we have already seen. If you're using a de-duplicator or a resequencer out in the fortress, you don't know where your business process stands right now, right? Because you're not modeling the business, you're trying to prevent uncertainty. So we let the uncertainty through, and now we allow the business state to reflect the stage that we have already achieved and where we might have recognized a failure condition, or at least some kind of severe latency. So here are some modeling heuristics that you can go by in this uncertain world that we're now dealing with. First of all, you don't own the time frame. As a developer, you need to engage with the business, not only for the ubiquitous language, but for determining what time frame is acceptable to the business for when these kinds of situations time out or reach some kind of a warning zone. You have to engage with the business to do that. And here's the thing, I'm just trying to protect you. Because if the CEO of a startup says, well, let's make it 5 minutes, and it ends up causing problems with customers, then the CEO can say, well, maybe it should be 10 minutes. If you say it should be 5 minutes, and it causes problems for the customer, that's a far different thing, right? So it doesn't belong to you. The second one is be uncomfortable, but make decisions. So go and bother the business, right? Okay, how should this work? What is the actual ordering? What is the full process that we should be capturing here? And when does it time out, or when does it become a dangerous situation? Tell the business, okay, look, we don't know the answer, but we have to take a good guess, right? So be uncomfortable, but try something, and allow empirical data to prove that you should move this time frame or whatever it happens to be, the design of the process, in one direction or another. Another heuristic is, of course, start with what you know. So this comes in with how do you model the events in the first place? Where do you start? Well, we start with the customer facing, the matching bounded context. And we say, okay, look, we know that we need a proposal for two individuals to agree on, a client and a worker, and because we need them to have some agreement, and the agreement is going to be over pricing and scheduling and maybe location and so forth, well, we start with that. We take what we know and we model the domain events around that, and then we figure out who's going to see those events, what events will be emitted out of those other bounded contexts, and a lot of that can be discovered through a technique called event storming, right? You can figure this out in a matter of hours. Okay, what I want to do now is I'm just going to switch gears a little bit here and show you some code. And I think I have at least 5 minutes, or I probably won't take 5 minutes, but okay. So in this source code, I have some Java code that can everybody kind of see this? No? Okay. Okay. I'm going to fail if I try to do something about that right now. But feel free to move up if you can't see. I'm sorry. So I'm sort of short on time. So here's what happens. We have a ubiquitous language. Part of that language is a proposal. It's a job proposal. A client has written this proposal. So we have the concept of our own proposal identity. We have a client, and we have some expectations of the client, and we have a progress, right? So we've modeled the idea that there will be progress made on the approval of this proposal so that it can ultimately be accepted or, taken by a worker to get the job done. So we have a static method, proposal.submit for client expectations, right? See how fluent it reads, okay? And then we have another one for proposal changed with. So this is actually, see where I have proposal.model.fn? This is just a little separation to show that this can be modeled in sort of a functional way. So this is actually an immutable entity in that the state of the entity is not directly mutated right here. See, all of its properties are final, right? So any operation that I perform has to render a new proposal instance, right? It's still the same proposal, but how do we do that? So let's say that we're going to deny pricing. We get an event from the pricing bounded context that says pricing denied. Ultimately, this is going to be turned into a command in the matching bounded context, and we're going to tell the proposal deny pricing. And here's the suggested pricing, okay? So we deny the pricing, but we're going to check to see, have we already seen this, right? Now, if Michael Feathers is here, he's going to say there's an if in this code. So I apologize, but I don't think that Java has quite the tooling it needs yet to be completely conditionless, but maybe I'll be set straight. In any event, if we've already seen that pricing denied, we're simply going to return a tuple 2 of the same proposal with no domain events, okay? So that's sort of telling the outside world, nothing changed, right? Ignore that, in essence. And now we simply, if we're not in that situation, we need to have a new progress with pricing denied. We have a new expectations with adjusted suggested price, right? And we have the domain events with, or a pricing denied domain event from our own bounded context. And then we're going to return the tuple of a proposal changed with new expectations, new progress, and we're going to emit the event if completed, which in fact we are completed now because we've already hit an error situation, and denied. So we're going to give the user, the client, the opportunity to rewind here and come up with a different price. I also have an example of doing this with event sourcing. It's just a different approach, but you're going to apply some domain event that comes from the process that we're supplying, and then we're going to transition our internal state based on when the pricing is denied. We're going to save away our new expectations and our new progress. So I hope that this code has underwhelmed you, that this whole presentation has said, this stuff isn't complicated. Model the uncertainty in the domain because that's where you're going to make progress within the business, and it's going to save you a world of hurt. So thank you for attending.
Yeah, thanks a lot. So maybe a few short questions. So how do you think events should be named by convention? Containing verbs?
Yeah, so name your events generally maybe like the name of the entity that's emitting them, such as proposal, followed by a verb in past tense. Other times it may just be natural to say pricing denied, but because it's within a specific namespace or package of a given bounded context, you know what this context means by this capturing a fact. So yeah, but use verb in past tense, and don't use the word event. Okay, don't model your aggregates as proposal aggregate. It's a proposal. Aggregate is not part of the ubiquitous language, right? An event is not part. Well, you may have an event in your ubiquitous language, but we don't use the naming of technical terms in our business model.
Okay. Are the code examples available?
Send me an email.
Okay.
Yep.
Final question.
I think I do have actually an email address.
Yeah, I did send you some emails, so there you go. Final question, would you sign my DDD book?
Absolutely, yes. Be happy to.
Okay. That's actually a question that came in through the app. And okay. I think we know who sent it in. Okay. Thanks a lot for the talk.
Thank you.